Alright, so no new information on 4.4. It's really just taking 3.4 and doing it twice, sometimes 3 times. And the inequality is because of these symbols. Gives you a dashed line, solid line because of these symbols. Okay, so again, try it yourself first. If you want to go ahead, go for it. If you want to wait for me, I'll start in just about 1 minute or so. Alright, those are waiting for me. Let's go for it together then. Okay, let's take the top inequality first. And remember, if it's solved for y, it's ready to be graphed. Ready to start here. And so we think about this as y equals mx plus b. There's my slope right here. My y-intercept. So let's start with this one. Start off with 1. So 1 should go right there. And then we have the 1/3. Remember, this one tells you how far you go up from that and how far you go over to the side. So we're going to go 1 up from our dot, and we'll go 3 to the right. So 1 up, 1, 2, 3 to the right. Now the only thing I suggest, because you're sort of overlapping lines together, numerous lines together, try to make a straight line as possible. So if you have a straight edge, that's great. If you don't, then just sort of keep extending your slope. So from this dot you go 1 up, 3 over. Cool. So then you have a nice clean line all the way across. Alright, and then also on the back side, instead of going at 1 up, 3 to the right, you can go down 1 and 3 to the left. Will also produce that line. And keep on continuing. 1 down, 3 to the left. Notice I have dots all the way across. So I'm going to be intersecting those points exactly where I need to do. Alright, and solid line coming across, arrows at the end. And we have our test point to deal with. So I'm going to pick test point 0, 0. And plug into the top equation here. Again, hey, this is just like 3.4. So true or false? That's true, huh? 0 is less than or equal to 1, so that's true. Alright, in that case, we're going to shade below the line. And then all we got to do, we just have to do it twice. Alright, starting with this one here, let me turn it to blue a little bit here, just so colors match a little bit. Alright, looking at this line, -3 is where we start along the y-axis now. So going along the y-axis. One up, 3 to the right. So from this dot, we're going to go 1 up, 3 to the right. Do that again, 1 up, 3 to the right. Hey, I noticed these guys both have the same slope, huh? That means these guys will be parallel lines, but that's okay, because we're looking at inequalities, not equalities. Okay, again, instead of going 1 up, 3 to the right, how about we go 1 down, 3 to the left, 1 down, 3 to the left. Solid or dash this time? It's a dashed line because of the greater than symbol. So again, arrows at the ends, and let's pick a test point. Alright, anybody? What do you guys want to pick? 0, 0, fine by me, right over here. So 0 is greater than 1/3 times 0 minus 3. And true or false? It's true. Alright, so we're going to shade up from the blue line. And notice what happens is you got a sort of double shade here. And kind of nicely for the computer, a green and purple make black. Kind of nice. But really what you want to do is you want to shade in this middle area here. So basically what we're saying is extends from the bottom, goes up to the top, and the shade is caught between the two lines. I used to teach at Fresno City College, and I used to teach the it's called decision sciences. How do we make decisions as far as business is concerned? Which is a kind of fun class. But it had to deal with this stuff right here. It had to deal with inequalities. I think we got one project was we had 16 different inequalities that we had to think of. When I was in my undergrad work at Fresno State, one of my professors, he was best friends with the accountant for Nike shoes. They have 96 different equations or inequalities to deal with. Imagine endorsement costs. They can only go so much, right? Distribution costs, raw material costs, workers' comp, packaging, all that stuff requires a different inequality. And so they are great in trying to figure out what's the highest price I can charge for this shoe. Interestingly enough, they have a formula for disposable income per family in a certain area, so they can actually tell based upon how much taxes there are in this area, based upon the gross income in the area, how much disposable income people have. I mean, it's interesting how all these things sort of look at it. Anyways, so I'm going to shade in that little area in between a lot darker. And then what I tortured my high school kids with, I made them erase the other ones they did. So they had to actually do this and erase there, and they had to give me just the middle. For you guys can just darken it in a little darker, that's fine. I'll be nice to you. Alright, cool. Alright, next one. This one, kind of different here. X is greater than or equal to 0, Y is greater than or equal to 0. If you got it, I think you already did it. But if not, I'm going to try it with you guys here. First of all, notice these things are kind of weird here, especially the bottom two inequalities. Normally, if this happens, again, normally, we usually graph these first, and then we deal with the regular sort of inequalities. You don't have to do it that way. Kind of just makes more sense to do it that way. So, dealing with this one here, x greater than or equal to 0, vertical line or horizontal line? Vertical line. It hits the x-axis where? Right at 0. So it's a solid line going straight down. Test point? Cool, 1, 1. Again, we have to be not on the 0, 0 anymore because the line itself goes through 0, 0. So for this first one, we're testing 1, 1. So no y to plug in, but I do have an x to plug in. Is that true or false? That's true. Let's shade the one that has the dot in it. Okay, where's this used at is when it doesn't make sense to have something negative. Another project we did, a project we were doing was raising chickens and raising pigs. It was one of those just to see what kind of profit you'll get, and is it worth going all chickens or worth just pigs or worth combination. And so we had to figure out, they had to figure out the selling price for pigs for that season. They had to figure out the selling price for chickens, how much feed you need. So here's all these inequalities coming out. How much space you need for them to run around in. Is it worth to go organic or not organic? I mean, all these things they had to sort of think through before they started. But really, can they have negative chickens? Nah, you can have 0 and you can go higher from there, but you can't have. And then same thing with the pigs. So they had to set up this right here. They only are working in quadrant 1. So y greater than or equal to 0, that's a horizontal line. It goes through 0 right here. So it's solid. And then we need a test point. All yours. 1, 1 again. Okay. To favor 1, 1. There's no y to plug in. There's no x to plug in. There's a y to plug in. So true or false? Yeah, it's true. So we shade up. So now really what we have you should think as you're shading, you think, where's the answer? The answer is just quadrant 1 right here. Okay, now let's deal with this one right here. Okay, on the previous problem, notice they were already solved for y. This one, they're not solved for y. If you like, you can. You can easily solve this for y. Before I get there. But on this one, it's a lot easier to solve by something called intercepts. Remember intercept method? And again, it doesn't matter. If you wanted to, you can subtract x here, and y is equal to negative x plus 3. The other one is making this little table. So if I were to plug in a 0 in for the x, what would y going to be? Now, if that's 0, y has to equal 3. Then if I plug in a 0 in for the y value, what's x going to be? 3. Cool. So again, quick, easy. You think you can do that in your head? Yes, because that's what it's made for. It's made for you not having to write stuff down. So I'm going to graph 0, 3 right there. I'm going to graph 3, 0 right there. And solid or dashed? It's a dashed line coming all the way down. So dashed line, hopefully yours is more straight than mine. There it is. And the shade, we've got to pick a test point again, huh? Let me switch that to black so it matches here. Test, what do you guys say? Yes, 0, 0 is good. Yeah, 1, 1 you could also test. It doesn't matter, either or. Plug them in though. And again, why is it easy to test 0, 0? Because the whole entire left-hand side will be 0. True or false? It's true. We're going to shade down. Okay, because these guys are all highlighters, all these different colors come out. But really, what's the answer? Yeah, that's that little triangle right there, that right triangle right in the middle of the whole entire thing, sending from the origin into the first quadrant. And again, I made my high school students all take everything out so I can know exactly what the answer is, and there it is. It's just that little triangle.
Is it always where they meet, or will it ever be like shaded here and shaded here?
Could possibly be shaded, yeah.
So you shouldn't just assume that it's the middle for
In fact, that's a pretty good thing to talk about. The question is it always sort of going to be in the middle of the graph, or is it always going to be the middle? Just by changing this inequality, I could have made it shade all below this line. Or just changing this inequality, I could have made it all graph above the line. So not necessarily in the middle. Most of them are going to be the middle, of course. All right, and this one. Let you guys try that one. Something about horizontal lines, vertical lines. Give you guys a minute or so. Try it yourself if you haven't done so already. All right, let's go for it as well here. So x greater than negative 3. That to me looks like a vertical line, is that right? Crossing the x-axis at negative 3, and it's a dashed line. So all that information without writing anything down. Let's go dashed, coming down, vertical line, and then a test point, of course. What do you say? Test point? 0, 0 is the good one. Again, no Y to plug in, just an X to plug in, so true or false. Hey, true, we're getting pretty good here. So shade everything to the right. So vertical line, dashed line, and shading off to the right. Wait up just a little bit here. I see a few people erasing here. Let them catch up here. Alright, let's go with this one here. So Y less than 4. Looking at this one here, that is going to be a horizontal line. Crossing the Y-axis at 4, and it's going to be dashed. So let's go with that one. Again, coming across, dashed line, and picking a test point. I go 0, 0, is that right? So I get no X to plug in. I do have a Y to plug in as a 0. True or false? True. So we're going to shade down from the line as opposed to up. And again, just by changing this inequality, I could have made it go up as opposed to down. But there it is. Shading the overlap darker. So we got it. And then, again, just so I can see the answer, so you guys can see the answer, taking those out. So there it is. You should have that little infinite rectangle that goes on forever this way and this way. And again, ask me the questions if you need to. You can handle it. Alright, and maybe a little bit of a toughie one here. Let's see. Give you guys a head start here. See if you guys can do that by yourself. Give you guys a minute, try this yourself. See if you guys can go from beginning to end and put in the answers. Cool. Alright, let me start it as well here. So again, I notice the first two inequalities are sort of similar. I know the one looks like a vertical line. I'm going to start from the bottom. I'm going to work with the vertical line first, then I can work with the rest of them. Don't have to do it that way. Okay. Customary, that's the way we do it. So x greater than 1, that is a vertical line. It's a dashed line, crosses the x-axis at 1, so comes straight down, arrows at the end, and I got to pick a test point. So I'm going to test, let's see, test 0, 0. The 0 plugged into that. No Y to plug in, but I got an X to plug in, true or false? It's false. So all we do is we just shade the opposite side. So our test point was here. That means all the other points on here will always be false. That means the points on this side will always be true. So there's my first graph. Alright, and again, you could solve this guy for y. What I think I would do, I would solve it by intercept method. So again, set it equal to 5. And again, you could do this in your mind if you like. You could do it on a sheet of paper if you like. If y, let's see, if x comes in as 0, what's y have to be? 5 is good, yep. There's my first point. Then if I put 0 in for the y value, what's x going to be? 5. Cool, there it is. So 0, 5, and 5, 0 are my points. 0, 5, there it is. 5, 0, there it is. Dashed or solid? It's a dashed line coming through. And again, picking a test point. I'd try 0, 0. So 0 goes in for x, 0 goes in for y, and then you know what? If they're all zeros, again, the whole entire left-hand side goes to 0, so I gotta ask myself true or false. That's true. Cool, so shade towards the 0, 0. Alright, one last one here, x minus y. I'm going to, again, convert it into an equality instead of inequality. Let me change it to the same color. So that you guys can at least see it the same. You know what, I think it's a different color here. I think it's this one. So, doing the x and y coordinates here, intercept method. Plugging in a 0 in for the x, what's y going to be? Yeah, it's going to be a negative y equals 5, therefore y equals negative 5. Good there. Plugging in a 0 in for the y value, like this, so that goes away. So I'm now left with x equals 5. Ooh, so slightly different because that little negative. So finding 0, negative 5 along the y-axis, it's going to be about right there. And then from there I'm going to go 5, 0. So this one's going to be over here. Let me do it with an arrow here so you can kind of see it's right here. It's actually underneath. It hits the same spot that we got last time here. So 5, 0. Dashed line coming across. And we got to pick a test point now. I think I'll pick 0, 0 again. 0, 0 is our test point for the green line. And it looks like 0 subtract 0 is still 0, so is this true or false? That's true. We're going to shade towards the origin. And that's going to be that green stuff there. And again, now it's all black and green and orange and blue. You got to figure out where is it overlapped 3 times. It's that triangle right there. And again, as you erase everything else, then you kind of see a little better there. It's caught between all 3 lines at the same time. Cool. Alright, and the last one is more like a word problem here. Let's just kind of go through it real quickly here. It says, in example 5, there's a college basketball game. They're planning to charge $20 for certain seats, $15 for others. But they also want to bring in more than $18,000 from all the seats available. But they also want to have on reserve at least 500 tickets for the $15 rate. So give it the discount rates. So the question really is, what kind of ticket combinations are possible? That's kind of what we're trying to find. So first of all, as we talked about earlier, does it even make sense to have negative seats available? No. So that's what these guys are for. So the $20 tickets, they can either be 0 or greater. $15 tickets could either be 0 or greater. Okay, no condition on the $20 tickets. However we sell, that's how many we sell. But the discount tickets, there has to be at least 500 of them. That's this one right here. That's the reserving the ticket values here. And then, if you take, remember how we did value for the word problems? We did number, then we did value. This is sort of like the value inequality. 20x, because $20 per ticket, plus $15 a ticket has to be greater than $18,000. And so if we look at that, the value equation and then the number equation. So notice these two are sort of like the number equations. Again, that's more like the value equation. Still same thing as the word problems for 4.3. If we do that, we get a graph that looks like this. So let's see, notice the vertical line. That's the y, x greater than or equal to 0. There's your y greater than or equal to 500, and there's the other part right here. So if they sell tickets anywhere in this area here, so 600 $20 tickets, 900 $15 tickets would put them in the area that they want to be in. Okay, now the question is this. How would the graph in figure 16 in the textbooks change if they had reserved only 300 tickets at the $15 rate? Which line changes? The black line, the blue line, or the red line? Yeah, it's the blue line, right? Remember they held it at 500? If we want to bring this down, we're going to bring this down to 300. It's going to go down to here. So the only thing that changes is this right here. As far as selling tickets, because you're looking at profits, normally you don't have something like this. Normally you have something like a dome that says, okay, this is the most amount of profits you can have. Well, it's usually on the outside and curbing you in. But anyways, it says the horizontal line, or you could say the blue line would move down to y equals 300. So the horizontal line or the blue line, whichever way you want to call it. Alright, and there's one more type that we got to deal with that was sort of not in the notes here. But I figure if we deal with it online, then I can show you how to do the work online as well as the weird one. So let's click off of here for now. Let's go to this, and I think I have it sort of. Okay. Alright, so notice it's a weird one. It doesn't have x's and y's. It actually has an x, but that x is actually caught between two things, or two numbers. The y does the same. Y is a different equation, but it's caught between two numbers. Yes, first of all, yes, we're going to actually have 4 different lines on here. And what the x caught between 2 different numbers means, it means that it's caught between 2 vertical lines. The 2 is where it sort of starts, the 5 is where it ends. So on the online homework, which I think you guys are more familiar with already, before you do anything else, you have to choose a dashed or solid first. That's the first choice. So solid line for this one. The first vertical line comes down at 2. So for the vertical lines, pick a point and just go down. Doesn't matter how far you go down. Just go down, click another point. Then you got to solve, sort of check between the 2 here. It started off at 2. It's going towards the 5, so it's going to be more on this side. There's another vertical line at 5, solid, so I don't need to change anything here. So solid here, it's going to be red now. And now it's going towards the 2, so there, oh gee, that's what happens. See, that's no fun. There it is. I can move these lines interchangeably. Okay, are we good there? So it's this little portion right here that's shaded twice. We still got to deal with this one. There's a horizontal lines. So the y value is caught between a horizontal line of -1 and a horizontal line of 5. So a horizontal line -1, and then the question always comes up, Mr. H, how do you draw horizontal lines? You click on it once, you drag it sideways only, like this. Click on it, and again, we're going to shade towards the 5, towards the y equals 5. And the last one, y is less than or equal to 5. And now this is going to be a horizontal line. And again, could start anywhere you like and goes anywhere you like. But we're going to shade down. So once you do all those shading, just kidding, didn't take here. So how about click, click, and click. There it is. So notice you don't need to erase anything. Notice you don't need to do anything else like that. The one that's shaded all 4 times, it's this little rectangle right here. But you don't need to say that is the answer. Okay. We just submit, and hopefully I get it right. Yay, there it is. So, okay, so this one again, caught between 2 vertical lines, caught between 2 horizontal lines. That's kind of what we're dealing with on that one. That's the weird one that you might end up seeing on the homework. Okay, so at this point, you say, Mr. H, I got some homework questions, stay. Or you say, Mr. H, I'm going to go. I got this exam. You guys can leave. Just don't forget 3x5 card, both sides, and your Scantron when you come in. Both sides. Both sides would be just fine.